Welcome to Ask and Learn.
A model for the shape of the bird's egg is obtained by rotating about the x-axis the region under the graph of f of x equal a times x cubed plus bx squared plus cax plus d, that value times square root of 1 minus x squared. That is, f is the product of a polynomial of degree 3 times the square root of 1 minus x squared. We're going to use cast to find the volume of such an egg in part A, and in part B, for a particular species, a red-throated loon, we have A equals negative 0.06, B equals 0.04, C equals 0.1, D equals 0.54. At particular values, we graph f and find the volume of an egg of this species. So, in part A, we know that the volume is generated by rotating the graph of this function around or about the x-axis. First, we determine where this function is positive and define, well, for this function we know that the domain is determined by the square root of 1 minus x squared, because the first part, the polynomial of degree 3, is defined everywhere independently of the coefficients a, b, c, and d. So for the square root of 1 minus x squared to be well defined in the real numbers, 1 minus x squared got to be non-negative, that is greater than or equal to 0. So the domain of f is the real number such that 1 minus x squared is greater than or equal to 0. If that's the same as the real numbers that are or have square greater than less than or equal to 1. And if we take square root both sides of this inequality, we get the real numbers such that the absolute value of x is less than or equal to 1. That's the same as the closed interval from negative 1 to 1. So the function is defined there. And in that case, we know that for some values of parameters, we will have a positive graph of the function. So in general, we know that the volume of the region in space determined by rotating about its axis, the region determined by this function. And the x-axis, we know this is given by the integral from negative 1 to 1, which is the variation of x. And then we have pi times the function itself square, because we have the areas of circles, something like this. If the function has, for example, this shape here, so we rotate this way, so we will have circles determined by or with radius equal the value of the function at each point. So this will be the diameter, and we integrate those circles between the limits or of definition of the function or the limits we have defined previously. So in this case, these limits are -1, 1, and then we have the areas of the circles are pi times the radius square, and the radius is the image through the function f of each point x between m and n, in this case between -1 and 1. So that's it. This is the expression. So this is the integral from -1 to 1 of pi times a x cubed plus bx squared plus cx plus d times square root of 1 minus x squared, all that square. And because we have a product here and pi is a constant, we take it out of the integral. We get pi times integral from -1 to 1 of ax cubed plus bx squared plus cx plus d squared times, and the square root of 1 minus x squared is 1 minus x squared. We could do this by hand, but it's tedious because we have 4 terms in a square, and then a multiplication is very tedious to do so. And we use a calculator or algebraic system in the computer. For example, I've used MATLAB. You can use Maple or another one. MATLAB, in fact, has Maple inside of it, so I'm using Maple in reality. So using that, cool, we have found that this integral is equal to 4 pi over 135 times 5a squared plus 18 ac plus 9b squared plus 42 bd plus 21 c squared plus 105 d squared. That's it. So this is the expression we get if we do this integral here by hand, but it's better to use a CAS, computer's algebraic system, and verifying that I've written correctly all the terms. That's it. And now we can do a particular calculation. And if once we have this, it's easy to calculate the volume for specific species. All we have to do is replace each of the coefficients a, b, c, and d here, this formula. We have done so. So for this particular species, we get that the volume is equal to 3,769 pi over 9,375, which is about 1.2630040225. I've given 10 decimals here. So this is the numerical value of the volume of the egg of the particular species given in the statement, the red-throated loon, and the general volume was calculated here using a computer algebraic system. And we found this expression here, which depend on the coefficients a, b, c, and d. And that gives us the volume of the egg resulting from rotating the region determined by the function, the given function, and the x-axis. The rotation is about the x-axis.